Slope-intercept form for linear equations. Before we start, this is a view of the Columbia River Gorge and Mount Adams taken on the Washington State side of the Columbia River. Nearby is a replica of Stonehenge. It is actually the Klickitat County World War I Memorial in Maryhill, Washington. We usually read this as y equals x. We could also interpret it as y is the same as x. If we start at 0, 0, and y is the same as x, then for every unit we move right, we move the same distance up. So we'd have a point at 1, 1, because 1 equals 1. Likewise, we could plot a point at 2, 2, 3, 3, 4, 4, and 5, 5. We could also plot points in between these dots, and we would end up with a continuous line. Next, we'll graph y equals 2x. For this equation, for every 1 we move right, we move up 2 times as far. If x is 0, y is 2 times 0, or 0. If x is 1, y is 2 times 1, or 2. Another way to think of this is moving up 2 and right 1 to get the next point. So we have a dot at 1, 2. We can plot a few more points. If x is 2, y is 4. If x is 3, y is 6. Then we connect the dots to represent all the points in between the ones we graphed. The number beside the x tells us how fast the line moves up, or how steep the line is. It is called the slope of the line. We use the letter m to represent the slope. No one knows why, but it is traditional. In this case, m equals 2. Here's another example. Y equals 1/2 x. The slope is 1/2. For every unit we move right, we move half that distance up. If we make our xy table, once again, when x is 0, y is 0. So we put a point at 0, 0. When x is 1, y is 1/2 times 1, or 1/2. So we can put a dot at 1, 1/2. If we try x equals 2, 1/2 times 2 is 1. We could have skipped the previous point and just moved up 1 and over 2 from 0, 0, to find this point. So we have a dot at 2, 1. We plot another point when x is 4, y is 2. Notice I skipped letting x be 3 so that I could avoid the fraction. So we put a dot at 4, 2. And we plot one more point if x is 6, y is half of 6, or 3. So we have a dot at 6, 3. And we connect the dots to draw our line. Notice that all three of these points pass through 0, 0. Any number times 0 is 0. Now for this example, we'll use y equals 1/2 x plus 2. If we add a number to the end of the equation, it increases the y value by that amount. In our xy table, if x is 0, y is going to be 1/2 times 0 plus 2, or 0 plus 2, which is 2. So we put our first dot at 0, 2. If x is 1, y will be 1/2 plus 2, or 2.5. If x is 2, y is 1 plus 2, or 3. So there's a dot at 2, 3. If x is 4, we put 4 into our equation and get 2 plus 2, or 4. And if x is 6, we get 5. So we have a dot at 6, 5. And we connect the dots to get our line. Notice the lines have the same slope. We call lines with the same slope parallel. Because this number determines where the line crosses the y-axis, we call it the y-intercept. We use the letter B to represent the y-intercept. In this case, B equals 2. The slope-intercept form of a linear equation is y equals mx plus b, where m is the slope and b is the y-intercept. We will use y equals mx plus b very frequently throughout your study of high school mathematics. So you should memorize this simple equation soon and keep it memorized. We can use the slope-intercept form to quickly graph linear equations and save time and effort. For our first example, we'll use y equals -2/3 x plus 4. Start by plotting the y-intercept on the y-axis. In this case, the y-intercept is 4. So b equals 4. We put a dot at 0, 4 on the y-axis. Then use the slope to find the next point. In this example, our slope is -2/3. So m equals -2/3. If the slope is a negative fraction, rewrite it so that the negative sign is in the numerator. So now we have -2/3. The numerator tells us how far to move up or down. In this case, since the numerator is negative, we'll move down. So starting with the y-intercept, we move down 2. We don't usually draw the arrow, we just count. The denominator tells us how far to move to the right. In this case, we move right 3. So we count 3 to the right and find our next point, which will be 3, 2. Now that we have 2 points, that's all we need, and we can quickly graph the line. Here's one more. Y equals 2x plus 1. Once again, we start by plotting the y-intercept, which is 1 in this case. B equals 1. So we put a dot at 0, 1. Now we'll use the slope to find the next point. In this case, the slope is 2. We want a fraction, so if the slope is an integer, rewrite it as a fraction. So in this case, we could rewrite the slope as 2/1. That tells us to find the next point, starting at the y-intercept, we go up 2. So we count up 2 and over 1. So we count right 1. We see that our next point will be 1, 3. And we can connect the dots to draw the line. If the equation is in y-intercept form, we can graph it more easily this way than by using an XY table, which speeds things up and will make your homework and your tests go that much more quickly and accurately.